now it's time to get started talking a little bit about review questions and some of the topics we've been doing in class. Many of the people in this class are looking to build a career in teaching. And one of the important things that I learned and came to realize over the course of my teaching career is that it does not matter how fast you learn something, it matters that you learn something. You know, when I taught, I used to give a test, and then when the test was over, if kids didn't do well on the test, and I defined well as anything 80 and above, I used to make the kids do a relearn packet. And the relearn packet, it was pretty cool. It would break the test down into different topics on the test, and they only had to do the part of the packet that reflected any sections they struggled on. And then we would go over this relearn packet together. They'd watch some YouTube videos, and then they would come to extra help, and I would make sure they're ready for the second test, and they would take it 2 times, sometimes 3 or 4 times. But what I noticed is that kids who struggled at the beginning of the year, after they did those relearn packets, by the time they got to like February of the school year, for the rest of the school year, they were consistently at or above an 80, sometimes even pushing 90. It was really a remarkable phenomenon to see. So it made me a strong believer in constantly going back and spiraling everything, reviewing it multiple times. Now, are there kids in class who do these questions once or twice and understand them and it's not an issue? Absolutely. For them, it's really not a big deal to do the question again. It keeps them current and brushes them up. But what about for the kids who did not get it the first or second time they saw it? Well, the fact that they get to see it again and again is a major benefit to them, and the vast majority will find a way to remember it, get it right, and prosper. So, with that in mind, here's our first problem. Make sure you draw a picture. And stop and start. Okay, so here's our picture. It's 8 feet by, it should say 15 feet there by 4 feet. I changed the numbers in the problem. I know I did those, but I didn't change it in the diagram. So that should be 15 feet. So 15 feet by 8 feet by 4 feet. Volume, we'll talk more about it later, but for now we'll go with length times width times height. When you multiply those out, you get 480 feet cubed. The problem is it wants its volume in cubic yards. So that means I have to convert. Feet to yards is small to big, and when you do small to big, you always divide. So the factor is 3, but it has to be a 3, and another 3 because the feet are being cubed. So basically, 480 divided by 3 cubed, which is 27, would be 17.7 repeating cubic yards, or 17 and 21 27ths cubic yards. Another way to look at it, for the conversion, is 480 feet cubed, and I'm going to convert to yards cubed, and each yard cubed has 3 feet in it, and that would come out to be, because all the feet go die, 17.78, I rounded off this time, or 17 and 21 27ths yards cubed. Okay, big thing you have to realize here, I think it's pretty easy to do 15 times 8 times 4. The big thing is to realize that you're going to end up dividing by 3 times as it appears in the bottom, or just 27 in the top. You have to realize that. And the way to remember to divide is to realize that you're going from small to big. Anytime you go from small to big, you divide. Think about it this way. If you have a bunch of $20 bills and you change them into $100 bills, would you have more $100 bills or less $100 bills? You would have less. You're dividing into it. Okay, go ahead. Okay, so area is 21 feet by 27 feet, which is 567 square feet. And that would be it. But it wants square yards. So I got to do a similar conversion, small to big, got to divide again. But this time, the feet is squared. So yes, there's 3 feet in the yard, but you're not going to divide by 27. You're going to divide by 9. 3 and then 3 again, which works out to be 63 square yards. Of course, you could have done it where you do the conversion factor, where you write 1 yard 3 feet, kills off the feet in the denominator there and the numerator, and you're left only with yards squared, which is 63. Or you could have said to yourself, hey, wait a minute, check it out. 21 feet is 7 yards, and 27 feet is 9 yards, so that altogether is 63 square yards. Okay, let's do a little bit more practice and reps here. This is going to be the last week where you see conversions between Celsius and Fahrenheit and formulas and stuff. Go ahead. Okay, so Here's our formula, F equals 9/5 C plus 32. I only remember the one. If you want to go with F minus 32 in parentheses times 5/9, you can go with it. It's not a problem at all, okay? Now, that's 9/5 of 30 plus 32. 9/5 of 30 is 54 plus 32. Adding them up, 86 degrees. So 30 degrees Celsius sounds chilly, muy frío. But then you put it into Fahrenheit, 86, you're like, muy caliente. So, you got to turn around and watch what you're doing there. All right. Next up, convert 50 Fahrenheit to Celsius. So this time the 50 goes in the place of the F, not the C. So first I subtract the 32, get 18, then I divide by 9/5.